Good evening, ladies and gentlemen. This is Mr. Simmons, and once again I'm doing the Pythagorean Theorem Part 2, which is finding one of the legs of a right triangle. So once again, we start off with saying that a squared plus b squared equals c squared, meaning that the legs a and b, I square a, I square b, I add them together, and it is equal to the hypotenuse, the long side c, being squared. So without further ado, I'm going to give you some examples. Okay, in example 1, I have this side is 8 foot, this side is 10 foot, and this is x. It's missing. So we notice that one of my legs here that makes the 90 is missing. So side x is missing. Well, across from the 90, we always have side c, so I'm going to label this side c. And then, of course, it doesn't matter which one you label A and B. I'm going to go ahead and label this one A, and I will label this one B. With that said, we have A is 8 feet, so I'm going to have 8 squared plus B, which is now going to be x squared. And then side C is 10, so I will have 10 squared. 8 squared makes 64. Once again, x just stays x squared, and 10 squared makes 100. Well, now I got to isolate this variable x. I got to get it all by itself. So that means that I got to get rid of adding this 64 here. Well, the only way to get rid of adding 64 is to subtract 64. So I'm going to subtract 64 from both sides. Of course, these 64s cancel because 64 minus 64 is 0, and it just leaves me with x squared. So I'm going to bring down x squared equals, and 100 minus 64 on the right side of the equation, that simply makes 36. Oops. Now, I have to take the positive square root of both sides to get to unsquare x. So I take the positive square root of x squared, and I also take the positive square root of 36. So the positive square root of x squared simply makes x, and the square root of 36 makes 6. So x is 6 feet, and I can box in that answer. Okay, let me show you one more example. This triangle looks a little bit different. It's kind of flipped around, but as always, I need to label my sides A, B, and C. Well, the easiest one to label is always across from this 90, which is always side C, the hypotenuse. And these other two legs are sides A and B. Well, before I had X was B, so this time I'm going to call it A. And that makes this one side B. With that said, A is going to be x, and I'm going to square that. And then I'm going to add side B squared, which is going to be 16 squared, equals side C, which is 34 squared, as I substitute in my values for A, B, and C. Now, x squared, I can do nothing with that, so it stays the same, and 16 squared becomes 256, and 34 squared is 1,156. Big number. Okay, now we got to get this variable by itself. We got to isolate x again. That means we got to get rid of adding this 256, which once again is subtracting 256. So I take 256 away from both sides of the equation. These cancel each other out, so it leaves me with x squared on the left, and 1,156 minus 256 leaves me with 900. Now I need to unsquare x, so once again I take the square root of x squared. And I also take the square root of the right side, which will be 900. The square root of x squared is simply x. And the square root of 900 is 30. So x in this problem is 30 inches. And I can box that in. Okay, ladies and gentlemen, so let's go on and look at our steps. Once again, we have to identify A, B, and C no matter how the triangle is turned. We always identify long side C first, which is the hypotenuse. And then we have the two legs that make sides A and B. And it really doesn't matter which one is A and which one is B, as long as they make the legs. So I identify my sides, I write out my Pythagorean theorem, I substitute in the values for A, B, and C, and then I simplify or solve. A hint that I can give you is if you're missing a hypotenuse, the long side, then you're going to add A and B together after you square them. But if you're missing one of the legs, either leg A or B, that's when you use subtraction. I hope this helps in you finding a missing leg on a right triangle. Thank you for watching.